Alright, guys, up here. Alright, section 8.6. Let's just write the name of it down, I guess. It's called the... We're going to do two things. The law of sines, okay, and the law of cosines. There is no law of tangents. It's just a law of sines, law of cosines. All right. Well, we've learned how to find missing sides and missing angles if we had a right triangle. So far, everything we've basically done is about a right triangle. Jacob, get your head up because you're going to need to pay attention. You have never ever done this up to this point. Okay. You may have done a little bit of trig stuff in Algebra 1 for those who are in like an accelerated program. You might have done a little bit of trig in there. Okay. So you looked at it and you say, okay, that's a little familiar. Pythagorean theorem. You might have done that. Okay. In Algebra 1, you might have seen a little bit of that. Okay, I promise you, you've not seen the law of sines and law of cosines in Algebra 1. This is probably the first time. I'm almost positive. Okay, it's the first time that any of you have seen this. So you need to stay awake. You need to keep your heads up. You need to pay attention. Everybody with me on that? All right, so law of sines and law of cosines. The reason that we learn these two things right here is when we don't have a right triangle. Everything we've talked about, Pythagorean theorem, trig function, sine, cosine, tangent, all that kind of stuff right there, we've always used a right triangle. What happens, though, if we don't have a right triangle and you need to find some missing angles and missing sides? Well, that's when the law of sines and law of cosines come into play right here. And you'll probably do more of this when you get into Algebra 2. You'll get a little bit more detailed, but we'll stay fairly general. We'll show you what the laws are, how to use them, and that's about it. Okay. In Algebra 2, you'll probably do a little bit more, get a little bit more specific, especially with the law of sines. I'll show you some things. Well, whoever your Algebra 2 teacher is will show you some things about the law of sines that I probably won't really hit in here. All right, just because it gets a little bit more confusing. So we'll try to keep this as basic as we possibly can. Let's change colors of these things. Let's call this A, we'll call this B, we'll call this C. We use the little lowercase letters to represent the lengths of the sides. And now watch what I'm going to do. I'm going to use an uppercase letter to represent the angles. Okay, we're used to that. We've seen that before. But watch, if I call this side A, and it's right here, I'm going to call this one, what do you think? This angle right here, what do you think I'll call that? Yeah, I'll call that A because it's opposite side A. You with me on that? That's pretty important as far as learning the law of sines. So if this is side A, this is angle A. So let's keep going. If this is side B right here, what am I going to call this angle up top here? We'll call that B. And then if this is side C, of course, this will be angle C. Everybody with me? Okay. So what we have, this is obviously not a right triangle, is it? So now, you don't know any of these angles, but we're just saying, okay, if you knew an angle or two, you could find one of the sides, or maybe you could find both of the sides. So we're going to be able to do things today that we weren't able to do just with the right triangles. And here it is. I'll just show it to you. This is kind of weird at first, but hopefully it'll make sense. Watch. I'm going to write A over the sine of A. This is our formula for the law of sines. Let's write it down. So law of sines. And as you notice, it has a sine in there, doesn't it? Sine of A. Well, watch what I have. A over the sine of A. So A represents what? This length right here. This capital A represents what? An angle, right? Because we're taking the sine of the angle. Equals B over the sine of angle B. Now this is kind of weird because I know what you're going to ask, Travis. Hold on. I'll say it. So A over the sine of A equals B over the sine of B equals what? C over the sine of C. This is kind of weird because you don't usually have three things equaling each other. But we kind of have had that. Remember we did the proportional triangles in another chapter, that kind of stuff. So we actually did have things that were equal to each other. And this is kind of what it is. It's kind of like a big proportion right here. But there's three things equal to each other. Now when we actually apply the law of sines, we're going to only pair up two of them. We're not going to use all three at the same time. Does that make any sense? So if I was going to apply this, I'll show you how to use it in a second. But if we're going to apply this thing, I'm only going to either use these two right here, or the first one and the third one. Okay, we're not going to actually use all three of them at the same time. Okay, Travis, tell me if I'm right on this. This is a question I think that he was going to ask. In the book, it looks like it's sine A over little a, correct? For some reason, it doesn't really make any difference, to tell you the truth. Okay, it doesn't make any difference at all. for some reason, I've always learned it like this, so I always teach it like this. Okay, the book will say sine of capital A over little a equals sine of B over B equals sine of C over C. It really doesn't make any difference at all. I don't know why I do this. It's just the way I learned it. It doesn't make any difference whatsoever if this is on top. As long as the angles are either all on top and the sides are all on the bottom, or if the sides are all on the top and the angles are all on the bottom, it doesn't make any difference. You just can't switch it around. You can't say A of sine of A equals sine of B over little b. You follow me? Either have to be, all the little ones have to be on top and the big ones have to be on the bottom, or vice versa. But it really doesn't make any difference which way you do it. I've always done it this way, so this is how I'm going to do it. All right, well, let's do this. There it is. There's your formula. Memorize it. It's not that hard to memorize, is it? It's pretty easy, right? Is there any what? Any acronym? No. There's no acronym. You just figure it out. All right, so let's put that triangle on here again. We'll use the same triangle. Make it a little bit bigger so we can work with it here. Now, it doesn't always have to be an obtuse triangle. This is just what they used in the example. That's why I picked it. Actually, I'll tell you what. Let's make this look a little bit more like the one in the book. So I'll just try to draw it out. So it looks like that. This looks slanted out a little bit like that. And this one goes about right here. All right? So this kind of looks like the example in the book. Actually, let's rotate it. There we go. That looks pretty close to the example in the book. So this is straight from the example. It's page 582 if you want to follow along, or you can just take some notes from this. And here's how they label it. This is A, B, C. And if I could see, there we go. This is 16. This little bit is X. This angle A is 97 degrees. And this is 21 degrees down here at angle C. 21 degrees. Alright? Alright, here's a situation. It's 97, right? Yep. Here's a situation that we could not do before, because we could only really deal with right triangles before. Right here, we don't have a right triangle, obviously. Look, that's 97, that's 21. I don't know, just for fun, what's this angle B going to be up here? Can somebody do that? 97 and 21, what's that? 118, is that right? 180 minus 118 is what? 72? Did I do that right? 62. 62? Okay. So that would be 62, if you wanted to figure out that angle. Because what they're going to ask you on a lot of these things, this one just says find x. But on some of these problems they're going to give you to do, they're just going to say solve the triangle. All right? What does it mean when they say solve the triangle? What do you think they're asking you to find? Yeah, everything that's missing, right. All the missing sides and all the missing angles, exactly right. Now this one just happens, this example just says find x, so you really don't have to find all the other sides and all the other angles, but you just have to find x. But there are problems where it says solve the triangle, and that means find all the missing angles, find all the missing sides. Does that make sense? Okay, so let's go ahead and figure out how we're going to do this thing. Let's write out the law of sines first so we can see it in front of us. Remember, it's A over the sine of A. What I would do, I was teaching, I don't know if you probably haven't done this yet, but it's called quadratic formula to my college algebra class. Anybody heard of that? Okay, and I told them for every single problem, I said, you're trying to memorize this formula, write it down on every single problem. Don't just write it once at the top of your paper and refer back to it. What I would do, if you wanted to memorize this thing, every single problem that you're going to use this on, I would write down the formula, just so that it helps you remember. Okay, so that's what I'm going to do right here. I could just always slide it up and just refer back to it, but if I write it down every single time, you don't have to do that forever, but at least when you're first learning these things, I would write down this formula every single time you're going to use it. Does that make sense? That'll help you remember it, because you will have to memorize this. Alright, so let's see what we're going to do. Well, what does the A represent? Well, the A represents a side that's opposite this angle A. Alright? And they don't always have to be ABC. This could have been angle X, Y, and Z, couldn't it? Alright? But what we want to do is this. Let's see if we can find a side and that we actually know, alright, and the angle opposite that side. So look, do I know one of my sides of this triangle? You said it. What is it? It's 16, right. Do I know the angle that's opposite this side? I do. It's 97. So that's always good. We always need one side and one angle opposite that side that we know. Does that make sense? All right, so that's what we're going to use. So I'm going to write it like this. Let's just do a different color. I'm going to write 16 over, what do you think? The sine of 97. Very good. The sine of 97. Everybody with me so far? So I take a side, and I take the angle opposite that side, and I take the sine of it. All right, so it's 16 over the sine of 97. Now, I set it equal. Remember, we're not using all three of these at once. We're just pairing them up. So I need another side. Exactly. I use the one that I'm trying to find. That's right. Okay, so I'm trying to find x. So what am I going to put here? X. Very good. And see, it's easy, isn't it? And you look across from it, and it's the angle is 21 degrees, and so that's the two that I'm going to use. See, look, I know these two, and I know one out of the other two. Make sense? So what am I going to write? Sine of what? 21, right. And there I go. And now, what can I do to solve for x? Cross multiply, exactly right. So I can cross multiply. Or, watch this. X is already on the top. So, instead of cross multiplying, that's kind of like two steps. I could just do one step. How could I get rid of the sine of 21 if it's on the bottom here? That's right, multiply it. Okay, multiply by the sine of 21. If I multiply this by the sine of 21, they cancel out. So what am I going to do over here? I'm going to multiply that by the sine of 21. Everybody see that? I'll get the same thing if I cross multiply, but cross multiplying, I would have to cross multiply, then divide. I would do two steps. This way, if x is already on the top, I just multiply both sides by the sine of 21. And now I'm ready just to plug this into a calculator. Okay, here we go. Here's my calculator, and let's punch this stuff in. So it's the sine of 21 times 16, or you could have written it 16 sine of 21. So watch how I'm going to put this in a calculator. I'm going to hit 16, and then the sine of 21. Now, if you just had a regular scientific calculator, not a graphing calculator, what I would do is this. I'd hit 21 sine, right? So you hit 21 first, then you hit sine, and then what would you do to multiply it by 16? Hit times 16, right? Okay, hit equals, right? And then put divide, and then put 97 sine, hit equals again, that should give you your answer. Okay, so if you're using just a regular scientific calculator, not a graphing calculator, that's how you would do that. But this is graphing calculator, so I go 16 sine of 21 divided by sine of 97. So I hit sine 97. I like to close that parentheses, hit equals, and there it is. It's 35 point, we'll just round it to 3. Is that all right? 35.3. So x is 35.3. Let's see if that's what they got. No, of course not. I know what I did wrong. I know what I did wrong because this thing defaults to something. I think I might have talked about this before. Did I? Yeah. What do I have to go check? That's right. I go to math right here. Oops, I don't go to math. I'm sorry. Go to mode, right. I know it started with an M. Look at this. It's in radians, isn't it? I don't want it in radians. I wish there was a way it would default because I always forget. So it's in degrees. I hit enter. So make sure it's in there. Now, if you have a regular TI-30 type of calculator, it probably already defaults to degrees every single time. Okay? But this one, for some reason, defaults to radians. And I kind of know why. Because when you start doing pre-calc and calculus, you're going to be doing, listen, you're going to be doing a lot of stuff in radians and not degrees. We'll talk about that some other time. Okay, we're not going to talk about it in here. In Algebra 2, you'll talk about radians and stuff like that. Just make sure it's in degrees. That's all you need to know. All right, hit, there we go. Now, let's try it again. Let's see what we get. So it's 16 sine of 21 divided by sine of 97. Let's see what we get there. There we go. 7.77 rounds to 7.8. Or I'm not 7. What am I saying? It's all the 7s. 5.8. So that's our answer right there. So x is 5.8. Now look, when I got that 35, I should have been able to look at this and say, well, wait a minute. There's no way this is going to be 35. Because look, 16 has to be the longest side out of this whole triangle, doesn't it? Because it's opposite the longest, or the biggest angle. Do you see that? Look, 21 is the shortest angle. So x must be the what? The shortest side. There's no way it could have been 35. Would you agree? All right, so just looking at my answer, comparing it to all the other stuff in the triangle, I should have looked at it and say, wait a minute, something's not right here. Okay, it is pretty easy, isn't it? All right, and there it is, right there. You good with that? Let's do another one. We'll probably do law of cosines tomorrow, and I kind of figured we would. So we'll just do one more with the law of sines. Yes, sir.
You can only do that when the x is on the top.
Wherever x is.
Well, if x was on the bottom, like if I would have written it the other way, you could have still cross multiplied and still got x. I just multiplied by the sine of 21. I just did it in one step if x was on the top. Okay, if x is on the bottom, I would cross multiply like I normally would do. All right, watch. I'll show you. Let's do this by cross multiplying. You watching? So let's take this original thing right here, and let's do this by cross multiplying. Just to show you, you'll get the same exact thing. So if we cross multiply, what do we get? We get x times the sine of 97 equals what? 16 times the sine of 21. Look what we do. How do I get x by itself? Divide by the sine of 97. So divide this by the sine of 97. Don't I get the same exact thing? Yep. See? That. And, yeah, right here. See? 16 times the sine of 21 over the sine of 97. I get the same exact thing. But I kind of had to do two steps here. Whereas right there, all I had to do was multiply by the sine of 21. And I was good to go. All right, I got a couple minutes left. We have to go on to the next one. All right. Let's, let me get one. Okay, here we go. I'll tell you what, I'm not going to use that triangle. Let's draw one that looks like the one in the book. Looks like that. Looks something like that. Looks something like that. Okay, let's do this quick because I'm running out of time here. I need a light up here. I can't see in the dark. It's 10. This is 45. This is x. And that's it. Okay, here we go. Let's write down the law of sines again. I said we should do this every time just so we remember it. Shouldn't take too many times to remember this, should it? Yeah, this is pretty easy. It's ABC, right? It's easy as ABC. Yes, little Michael Jackson. Thanks, Demir. All right, so here we go. Yeah, that's the Michael Jackson that I liked. When he got older, he got a little freaky, but I liked him when he was a kid. He was pretty cool. So here we go. Let's do this. First of all, here's the angle. This is 45 degrees. How are we going to set this up? First of all, we want to look for a side and an angle opposite that we know. So I know 8 and I know 45, don't I? So I'm going to go 8 over what? The sine of 45. Now, what are we trying to find? Trying to find x. Now, this is an angle, isn't it? It's x degrees. So how am I going to set that up? What am I going to put on top over here? 10, right, because 10 is opposite the angle we're trying to find. So 10 over what? Sine of x. Now watch. The law of sines really wasn't that big of a deal here. That was pretty easy to do. But the math might be a little bit different. But it's something that we've done before. So what are we going to do? We're going to cross multiply. So if I multiply those together, I get 8 times the sine of x equals, multiply these together, what do I get? I always put the 10 out front and then sine of 45. Everybody with me so far? Now, what do I have to do? I want to solve for x, don't I? But what do I want to get rid of before I try to get x by itself? The 8. How do I get rid of the 8? Divide by 8, right. Divide this by 8 and divide this by 8. But what do I have? I have the sine of x equals all this stuff. I want just x. How do I get rid of that sign? Take the inverse sign. That's right. Remember that? We don't divide by a sign because a sign's not a variable. A sign is just a word that indicates a certain relationship in my triangle. So I don't divide by the sign, but I can do the opposite of the sign. What's the opposite of taking the sign of something? Taking the sign to the negative first, or the negative or the inverse sign. Does that make sense? Okay. So this is what I'm putting into my calculator right here. And you have that button on your calculator, don't you? Sine to the negative first. So here's my calculator. Turn it on. Make sure I'm still in degrees. I am. Okay. So let's just clear this thing, make it nice and neat. So what do I hit? Second function sine. That's right. Let's do this real quick. Second function sine. And then we put 10 You know what I'm going to do? I'm going to put a parentheses before this 10. I don't know if you really need it or not,
Boys
but I feel
lacrosse,
better if I
boys
did.
baseball,
10
any
sine
boy that
45
puts equipment in the locker room
divided
for
by
baseball or
8.
lacrosse,
Close
please
that
report to the locker
parentheses.
room right now. Thank you.
Actually, I don't
I'm
know.
still missing one
I don't
permission
know
slip
if I
for the
need that
limo lunch.
parentheses.
Could you
Anyway,
bring
I'll put it out.
your
It won't make any
permission slip to the
difference.
office,
Watch.
please? Thank
There
you.
you go. So it's 62. So it is 62 degrees. So x is 62 degrees. That's how you do that. So you'll find both of those. Let me give you some work to do. What do you think? I'm going to forget? I told you from the beginning of the year it'd be every day, didn't I? Why is that a surprise? Look, it's page 587,
How about just one day every 2 weeks?
number 12 to 28. Look, this is how you learn right here. This is how you learn. You don't learn by sitting there watching me do these problems. You learn by doing the problems yourself. No, you don't. You learn by doing the problems yourself, okay? So get those done. That's due tomorrow.